Ladies and gentlemen, let's begin with another projectile problem that's based on an object that is being dropped. This is the page you should be taking notes on. The question we're addressing is this one right here. So this is the question that should appear across the top of your page. The boy drops the ball from a 125-meter tall cliff. How long is the ball in the air as it falls? We have to extract from this question both the implicit and explicit information and also determine what it is we're looking for. What is this question asking us to do? So, drops. The boy drops the ball. That tells us a number. That tells us that the starting velocity in the y direction is 0. We know that because he didn't throw it upward, he didn't push it downward when he threw it. He simply released it. So that gives us that starting velocity in the up and down direction as 0 meters per second. The next piece of given information is easy to spot. It is 125 meters. But from that 125 meters, we actually have two pieces of given information. We know that because we're going to go ahead and put our frame of reference at the release point of the ball, we're going to start have that be our starting line, then yi will be 0 meters, and the final position will be negative 125 meters. It will be negative 125 meters in the final position because we will take down as negative. So it's important to include that bit of information. Then the next piece of this is what we're actually trying to find out. We're trying to find out how long the ball is in the air. So we want to know how much time it took for the ball to fall 125 meters. Make sure that you have made these notes on your picture. You have included that up is positive and down is negative, that you have given the starting position at 0 meters and the starting velocity in the y direction as 0 meters per second. It's absolutely imperative that you use these subscripts exactly this way. That isn't negotiable. We're going to have several different velocities as we do more projectile problems, and it's key to have the correct subscripts on those velocities. So this is a velocity in the y direction to start with. That's what VYI means. Then here we have another variable with a subscript. This tells us this is final position of y sub f at negative 125. So the details are very important on these problems, ladies and gentlemen. All right, now inside this yellow box, be sure that you have listed all the variables there as well. I know it seems a little bit redundant, but it's just excellent practice, and it's something that I'm going to require that you do. Again, you're going to make sure that you're very diligent about putting in the correct variable names and subscripts with all of these values. Notice that we have listed that acceleration of gravity as one of the given pieces of information. So we will round 9.8 meters per second squared to 10 meters per second squared so that our calculations are a little bit easier to handle. And since we've designated down as negative, the acceleration of gravity will be a negative number. Now that we have all of that filled in, we can come down and select the equation that's going to help us, because we have also determined that our unknown variable is time. So given that our unknown variable is time, we can very quickly eliminate this last equation because there is no variable for time in that equation. That equation won't get us what we're trying to solve for, so we're going to immediately eliminate it. The other two equations both do include t as a variable. This equation has a starting velocity for y right here. It requires the acceleration of gravity, time, which is what we're solving for, but this is problematic because one of the variables in it is the final velocity of y, and we don't know that. So this is an equation we cannot use because there are two unknown variables in it. So we're going to be using this long one again, But if you remember from the last time we did this, it really becomes short very quickly because this goes to 0 and this goes to 0. So we only have one term on this side of the equation when we start to simplify it. So over this in this yellow box, I want you to write out this equation, please. Do not skip that step. Write out the entire formula just like this. And in your next step, you will drop all the values into that equation. So your next step should look something like this. Negative 125 meters is the value for the final velocity of y, so it starts this side of this equation. Equals 0 meters plus 0 meters per second times t plus 1/2 negative 10 meters per second squared times t squared. I do feel like I need to caution you about one thing that I've noticed that students do very often, and that's that they get confused about the t and the plus. If you're not careful with your handwriting, you won't be able to tell that you have a variable t and a plus sign. So be really diligent about making sure that whatever way you choose to make the t, that it looks like a t and not like a plus sign. When we go to our next step to simplify this, we have negative 125 meters is equal to negative 5 meters per second squared, because we take 1/2 of negative 10 times t squared. Remember, our target variable here is t. So in order to get t by itself, in our next step, we're going to have to divide both sides by negative 5 meters per second squared. And when we do that, and I flip the equation around, we have t squared equals 25 seconds squared. We're not finished yet because we don't want to know what t squared is. We want to know what t is. So in order to determine what t is, we take the square root of both sides. And when we do that, we find that t is equal to 5 seconds. So it takes 5 seconds for the ball to fall 125 meters.